No one launches more scientific balloons from more places around the world than NASA's Columbia Scientific Balloon Facility, based in Palestine, Texas. They can fly that 8,000-pound payload, the weight of 3 small cars, nearly 23 miles high, to an invisible ceiling where the atmosphere ends and space begins, and can stay there, riding upper atmospheric winds, for up to 6 weeks. They expand to nearly the size of a stadium, like the Louisiana Superdome. From New Mexico to Arctic Sweden and Australia to the coldest and driest continent, Antarctica. The Columbia Scientific Balloon Facility launches 15 to 20 balloons a year over 4 to 5 campaigns. It begins with the pickup of a scientific payload with a specially designed launch vehicle.
And attached to the payload will be suspension cables that will go upward to what we call a truck plate. That truck plate is actually holding the entire flight system to the launch vehicle. From that truck plate, there will be a suspension ladder that will go over the launch vehicle, and that will connect down to the parachute separator unit.
Rotators should be on.
This unit separates the parachute from the payload to prevent a wind-filled parachute from dragging and damaging the payload after termination. The nylon parachutes range in size from 46 feet to 159 feet in diameter for the largest payloads.
And then we'll have the terminate fitting, which is the link between the parachute and the balloon. That terminate fitting will have an explosive device on it that we'll initiate to bring the balloon down at the conclusion of the flight. And then connected to the terminate fitting will be the balloon itself. And on top of the balloon will be helium valves that will open at the end of the flight as a secondary measure to terminate the balloon.
Telemetry, the ability to send and receive data and control functions to and from the payload, is tested and confirmed. CSBF meteorologists closely monitor weather conditions to identify a favorable and time-specific launch window. Surface winds for a launch cannot exceed 6 to 7 miles per hour.
All right, guys, we're ready.
Stand by. Release the balloon.
Roughly 2 hours of float time, balloon and payload will arrive at the edge of space.
We've had reports from airline pilots that they could see our balloon and were trying to report near misses to the FAA when the balloon is 125, 145 miles away. From the ground, you can probably see it well in excess of 100 miles. We have a requirement to keep a chase aircraft essentially within 1 hour of flying time from the balloon at any time. What we have is...
While Stepp and his team monitor the westward tracking balloon in real time with sophisticated software.
The safe distance standoff distances are 5 miles in radius around the projected landing point of the payload, and we make sure that there are no populated areas within that area.
After a visual inspection of the projected landing point, a telemetry command is sent, firing an explosive squib that separates parachute and balloon at 120,000 feet in the air. This separation also creates a tear in the balloon, releasing the gas.
The payload descends on the parachute over a period typically of about 50 minutes.
The aircraft will stay in station right around the payload and monitor the descent of the balloon and the descent of the payload.
Once the payload is on the ground, there's a set of sensors that we fly that can tell that it's on the ground, and at that time a set of explosives is fired that separates the parachute from the payload to keep it from dragging in case there's strong winds in the impact area. We have the capability of predicting where a parachute will go from 120,000 feet, typically within 2 to 3 miles.
In the end, the payload is recovered and returned to the science team to fly another day. Scientific ballooning, the best kept secret in space science.
It's a quiet little engine that always has. And we've been going along providing very economical platforms for scientists since the late 40s. And I really believe that it's the little engine that always will, too.